So when I'm working through a problem involving motion, the first thing I look for is whether the object is moving with constant speed or it accelerates. And in this case, I can see that the object does accelerate at 8 meters per second squared. I also look for whether time is being involved in the problem. That usually leads me towards a certain set of equations, a certain set of patterns to be looking for. So since this question mentions time, I know that I need a formula that involves acceleration, it involves time, and then it also needs to provide a way to find distance or displacement. Now, the formula that I have in my mind right now, the way it's written on our AP formula sheet, looks something like this. It involves quite a bit of subscripts. It's a little messy looking. Okay, I want you to be aware of this so that when you look on the formula sheet, you see it and you know what this means. But what you'll see me do, and I think what most students will do, is they will, rather than think of an initial and a final position, they'll think of that instead as just delta x, or sometimes people like to use d. Instead of worrying about these subscripts, we tend to just write v sub ot plus 1/2 at squared. Now, the reason why they are listed this way on the formula sheet is because it's reminding us this formula can only be used when the velocity and the acceleration point along the same direction, when the motion is linear. Later we'll get to projectile motion, we'll get to circular motion, and we'll see that this equation needs to be used with care in the case of projectile motion and cannot be used at all in the case of circular motion. So in this case, we would go through and plug in the values. There's not a lot of algebra to be done here, just kind of plugging and chugging. I'm going to go ahead and include the units in my work so that you can see how that does help you make sure that you've got everything entered. The units should all cancel to give me terms that have the right units. Okay, so this is a displacement or a distance that I'm looking for, and so I expect that both of these terms have to end up equaling meters so that they can be added together to determine a final answer. And sure enough, the seconds cancel here, so this term would be just in meters. And here I have 3 seconds squared, so the unit is also squared. 1 second cancels with this, and the other seconds unit cancels here. So again, I end up with meters. Now, a lot of students at this point will start writing in a lot of individual steps showing all of their algebra. Please note, this is a physics class, not a math class. I would prefer if you get in the habit of just grabbing a calculator at this point, putting it all in one step, and seeing that your answer comes out to be 96 meters. That's going to save you a whole lot of time, and our problems will be much more complex than this in the future. We don't want to be wasting precious seconds on little algebra skills. All right, in this next question, notice that the phrase constant speed is specifically stated. Okay, and so that is going to be very important here. We want to make sure that we take that into account. Now, you may have in your head already be thinking, oh, constant speed, distance equals velocity times time, or v equals d over t, maybe v equals delta x over t. You know, there's lots of ways you can think about this. I do want to show you how that last equation that we used does have the ideas of constant speed sort of buried inside them. Let me get that equation down here again. So this equation can be used in the case of constant speed if we just recognize that constant speed means zero acceleration. And so we would just cross off this last part. Anything times 0 would be 0. So you can see that this equation here looks very similar to this equation over here. And so both represent the pattern between distance, time, and a constant velocity. Now you are welcome to plug in your values right away here. 190 is equal to 24t. Okay, it's a little harder to put units in when you're plugging in and then doing the algebra. If you think the units idea is really going to be helpful for you, you may want to do your algebra first. Okay, so that would look something like this. We would solve for t by dividing by the velocity. Okay, and then when we plug in our values, we could include the units, and we would see that the seconds cancels. I'm sorry, the meters cancel, and the seconds pops up on top. Okay, and again, you would be doing the same algebra, 190 divided by 24 with either setup. Now the answer here comes out to be, kind of a crazy decimal on my calculator. I'm going to write it out here, but I don't want you writing out that many digits on your paper. What would be a good place to round here would be actually about 7.9 based on the information given in the problem. This number of 24 has 2 significant digits, and so using 2 significant digits on my final answer would make sense. Now, if you wrote 7.92, am I going to mark it wrong? Is the AP test going to mark it wrong? No, not at all. Okay, it's just giving you a rule that you can follow so that things aren't too crazy. Now, an exception to this is that when you use our online practice that we're going to be doing, you may be using this answer in a later part of the problem. There's a lot of times there's multiple steps or multiple parts to a problem, and if you round this much in part 1, then in part 2 you may end up getting the answer wrong because you have rounded. And so it is good to use a few more digits in that case, maybe 7.917, okay, so that you maintain the accuracy. We'll talk more about this as we go. Just please ask questions as are needed. Okay, so taking a look at this question, let's kind of take a quick glance at things. Notice we're being asked to find acceleration, okay? But there's something that's missing that's in a lot of problems, and that is time. So the fact that there's no time mentioned in this problem, and it's not given to us, it's not being asked for, that really points us in a very specific direction. Okay, this equation here involving different quantities being squared, v squared equals v sub o squared plus 2 times a times the displacement. This is a derived formula where the time has been eliminated, has been removed algebraically from using 2 different equations. So this is very valuable. It's a quick one-step way of solving this question. You actually could approach this question in other ways, but this is the most straightforward way. In this case, I am not going to plug in my units. It gets a little bit messy to do that. But before I do so, I do want to notice just kind of one more thing here. Notice that the bus's speed is reducing down to 0. So that's telling me that my final velocity is going to be 0. Officially 0 squared, but of course that's just 0. And it also tells me to expect a negative answer for the acceleration because the bus is slowing down. So I'm going to put in the initial speed of 40. Make sure I square that like the formula tells me to. My acceleration is my unknown, and then I've got 500 as my delta x. Now, again, I would love if you could sort of see the process of doing the algebra in your head and just do this on your calculator. That would be great. But a lot of times people do need at least one extra step, but please be efficient in it. Okay, so if you need to include this extra step, 40 squared is 1600 I can choose to do the 2 times the 500. Let me do all that. Do both of those steps together. And then hopefully you can see that to find the acceleration, we would bring the 1600 to the other side. Negative 1600 divided by 1000, we would get negative 1.6. Okay, so again, I would love for people to be able to do some of that algebra just using their calculator, not having to write everything down. See if we can save a few steps. Now, the problem did not really specify a direction and so forth. This is a question that would be accepted as either positive or negative 1.6 meters per second squared. That negative sign really just refers to a direction, and that isn't particularly clear in this case. All right, and in our last question here, note that the problem is asking for the initial velocity. Okay, initial velocity is actually a quantity that is in like every type of kinematics equation, so there's really lots of choices here. I do want to notice that time is given in the problem, so that last equation is not going to be useful. And I want us to notice that there's no mention of distance or displacement. Okay, and so this is where we would want to use this equation here. Again, this equation looks different on our formula sheet. Okay, they will put in some subscripts here. Okay, but you are certainly not required to do that. I just want you to recognize it. This is likely how you were taught. Okay, again, you could do your algebra first if you prefer to do that, or we can just plug in what we know. The final velocity is the 21. That's what's happening later in the problem after the 5.5 seconds. The initial velocity is the thing I'm looking for. My acceleration is 3, and my time is 5.5. Okay, again, if you would have preferred to include units, if that helps, let's just kind of look to see how that looks. And you can see here then that the 3 meters per second, when we multiply that by 5.5 seconds, we can see how the seconds unit cancels, and we do get meters per second for this term, which means we're allowed to subtract that result from the 21. Okay, and again, I would love to see you be able to do this sort of just on your calculator. We end up taking 21 and subtracting the result of 3 times 5.5. So 21 minus 3 times 5.5, that comes out to be 4.5 meters per second as our answer.